Hello everyone, welcome to Anna Videos. You've probably seen thousands of light switches throughout your life. And yet, have you ever seen the inside of a light switch? Also, have you ever wondered how 2, 3, or more light switches can be wired together and used to control the same set of lights, such as in the case of light switches positioned at the top and bottom of a stairway? Well, in this video, we're going to explore the engineering inside the humble light switch, as well as how multi-way light switches work. So stick around and let's jump right in. Here's a basic light switch. When you flip the switch from off to on, this circuit becomes closed. A path for electricity to flow is created and the light turns on. When you flip the switch off, the path breaks open and the light turns off. The part that you flip up and down is called the toggle switch or handle. And when you flip it on a plastic leg at the bottom of the toggle, switch releases the metal contact bar. Or track, this metal contact bar springs upward, thereby allowing the two contact points to touch and electricity to flow from one screw terminal to the other, thus closing the circuit and powering the light. However, when the toggle is flipped off, the plastic leg at the bottom of the toggle switch presses against the metal contact bar and separates the electrical contacts, thus disrupting the flow of electricity, opening the circuit, and turning off the light. There are a few other key components that enable this light switch to function properly. First, there's a spring in the center, which presses on the bottom of the plastic toggle switch. This spring is positioned so that it's compressed when the toggle is in the middle of the on and off positions. The spring applies a force to the bottom of the toggle switch, which ensures that when the switch is not being flipped, it's either fully in the on position or fully in the off position and not somewhere in the middle. The second key component is a pair of bumpers, which limit the motion of the toggle switch and provide a solid surface for the toggle switch to bump into. Finally, we have the screw terminals for attaching wires, the metal bracket for attaching the light switch to the electrical outlet box, as well as the screw terminal for a ground wire, the plastic housing that keeps everything contained, and on top of everything is the faceplate that can be either simple or ornate, with the functionality and components of a basic switch wrapped up. Let's now take a look at multi-way switches, specifically three-way switches, which are used when we want to have two light switches control a single set of lights. For example, in my house, we have one three-way light switch at the top of the stairs and another one at the bottom, and they both are used to control the same stairway light in contrast to the basic light switch. Three-way switches have a common terminal and two traveler terminals. Now, when the toggle switch is flipped, the common terminal moves from being in contact with one traveler to being in contact with the other traveler. These travelers are a pair of wires that travel through the walls in order to connect one light switch to the other. When we flip the toggle of one of the three-way switches, a path for the electricity to flow to the stairway, light is created and the light turns on. However, when we flip the other three-way switch's toggle, the path is broken and the light turns off. In general, if both toggles are flipped down or both toggles up, the light turns off to turn the light on. One toggle needs to be up and the other down. Let us take a look inside one of these three-way light switches and see what is happening inside. Here we have a metal bar or track connected to the common terminal, along with two traveler metal bars, each connected to their own separate traveler terminals. 1. We flip the toggle switch. One traveler is pushed away from the common by the bottom of the toggle switch, while the other traveler is in contact with the common. The shape of the bottom of the toggle is critical and makes it such that at any given time, only one traveler is in contact with the common. Now, let's say we want 3 or more light switches to control a single set of lights. To do that, we have to use 1 or more 4-way switches with a 3-way switch at each end. Here's the schematic. Instead of a common and 2 travelers, as we saw it in the 3-way switch, 4-way switches use 2 sets of 2 travelers. When the toggle is flipped, the 2 pairs of travelers on the left change to being connected to the opposite traveler. On the right, here's a brief animation showing how the path of electricity is closed or opened and the light turns on or off depending on the position of each switch. When we open up the four-way switch, we find an even more complicated layout and yet a familiar set of components. The bottom plastic leg of a toggle switch presses down on the one contact bar when toggled up and presses down on the other contact bar when toggled down. As you can see, the path of the electricity is flipped from each pair of traveler terminals to the other pair. When toggling the switch from the up position to the down position lights switches are practically everywhere, and as a result, there are dozens of different designs, internal mechanisms, and methods for wiring the light switches together, but unfortunately, we can't cover them all. Note that this video isn't a guide to the installation of light switches, which is why we avoided using the terminology of hot, neutral, and ground. Please do not install light switches unless you are a professional or you are fully knowledgeable about what you're redoing. You can also provide support by subscribing, liking this video, commenting below, and sharing this video with others.